We've been talking about DC hardware a lot, also yesterday. And we have another great speaker and also a really interesting, fairly new, not really new, but up-and-coming player on the market. So we're really happy to have Kempower again here at the ICNC. Obviously, many of you have probably seen talks in the previous years. So next, we'll be talking about smart charging trucks with CCS and MCS. And for all of those who care about trucks, we'll also be discussing truck charging later this afternoon. So mark your calendars. And now I'm really happy to welcome Han Dix, Country Manager and Head of Sales Benelux at Kempower, on stage. Have fun.
Thanks. Wow, that's a lot of lights. First, I want to thank the ICNC for choosing the color orange, because as a Kempowerian and a Dutchie, orange is always a good choice. Thanks to the gentleman here in the front. Nice shirt. Yeah, so I'm going to tell you something about what we think is necessary for the truck market and also other markets in the future. So the agenda will be like this. I will tell a bit about Kempower for people that don't know Kempower yet. Why choose electric trucks? How do we charge them in the future? And also other machinery. And then also a bit about the smart charging combined, so CCS and MCS, and a small summary afterwards. So Kempower in a nutshell. We are a Finnish manufacturer of DC chargers based in Lahti, Finland. We have 3 factories there and 1 in the US, in North Carolina. Our background is in welding, so for 70 years we have developed welding from AC to DC. Welding is the same technique, basically. We make our own power modules in-house, which is quite special, I think, and we are proud of that. Firstly, it was done by Kempower, now actually, and that's our mother company. But now actually it's completely taken over by Kempower, so its own people making the material from scratch. When I started 3 years ago, there were about 40 people in Kempower, and right now it's over 800. So if you calculate that back, it's like 1 person a day. So that has been a massive growth, resulting in this nice map, where we have supplied in more than 50 countries our chargers. And as I'm from the Benelux, we also had nice projects there, many markets, so bus, truck, cars, CPOs, you name it. So why electrified trucks? Or why choose electric trucks? Of course, first of all, the CO2 emissions in the transport sector. This is where I have to look at the screen, because otherwise I don't know all the things by head. But of course, it's, I think, a no-brainer for everyone. Everyone is here to actually make the world a better place, be more sustainable. So we have to make sure we work on these goals, right? So the CO2 emissions are the biggest choice, in my opinion. But also, looking at the tank-to-wheel efficiency of the different types of material you can actually put in a truck, let's put it like that, or in a different vehicle. So diesel, green hydrogen, which of course, I'm not sure there's many enthusiasts for hydrogen in this audience, but let's see afterwards if there's a question. And of course, normal electricity, let's put it like that, like gray electricity. And then the green or the renewable electricity, you can actually see the tank-to-wheel efficiency is there. And I think it's, again, a no-brainer to go in this direction because of these clear figures. But there's also a clear market potential, of course. We're all commercial people, I think. And this market is worth 13 billion euro. So let alone that we have 50 million EVs in Europe, being 44 million cars and also 500,000 trucks, which is, of course, and then, of course, we also look, from a Kempower perspective, we also look into, of course, North America, which is, in my mind, 50 countries in one country, but yeah, of course. But what surprised me a bit, because, well, these studies have been done by our own team, and 44% of these truck trips are between like a maximum of 50 kilometers. Your last mile delivery, your shoes being delivered at your home. It's 44% of that. But 90% falls into 300 kilometer range. 90%. That means that the current trucks on the market, the Volvo FH Electric, the e-Actros by Daimler, or to name a few, they all are already doing the work for 90% of the whole truck trip distribution, which is quite remarkable. So we are talking about, and maybe it's not that positive than in that case of my story, but I'm talking about the last 10% in my next slides because of the MCS is being needed. I think for the majority of this chart, CCS is sufficient. So how do we charge in the future? So we have defined a few types of ways of like trucks charging. So overnight, of course, depots, e-truck, stops. You have a long period of time, 6 to 8 hours. You want to, of course, use the full 6 to 8 hours to charge the truck. You don't want to charge the truck between 2 to 3 hours because of the peaks. You have to run an electricity network, of course. You want to save money. So you want to make sure you charge the truck as efficient as possible. Later, I will show a bit more about that. Then we have destination, so warehouses, distribution centers. About like the unloading of goods, 30 minutes between 2 hours. Could be with high power CCS, so liquid cooling, or maybe even a bit a step up. And then we have, of course, the on the move. So we have, of course, also some CPOs outside that will focus on purely on the move, highway charging, where you have 45 minutes, which is the regulation, to charge as fast as possible. And that's, well, of course, if there's an MCS available, you should do it in the future, to be within 45 minutes on your way and full, or at least 80% full. So the 4 needs, I already said it. So the 45 minutes, and in the US it's 30 minutes. In that period of time, we need to make sure that the truck driver can, as fast as possible, can charge the truck to be as full as possible. So what do we need for that? Of course, we need higher power. We need the MCS, we need the megawatt standard to provide that. But of course, as you all know, I was reading some article, I think yesterday, beginning of 2026, some OEMs have now said, okay, 2026 we will start creating the MCS on trucks. So, of course, I'm now telling, well, we're talking about something in the, I think a lot of megawatt chargers are already outside, but the trucks are not there yet. So we need something in between. We are in a transition phase. So we need a bit higher power on the MCS, on the CCS level, so above 500 amp, to actually bridge a gap. And then, in our minds, it should be a dual strategy. So combining the MCS with CCS, so that you can invest now in your MCS setup, but probably not use it yet because of you are waiting for the trucks. But you don't want to invest now in a system which can't do MCS, right? A bit later on that, like how does that look and timeline-wise. But also I've put here everywhere, not to quote Fleetwood Mac in this case, but just to show you that it's happening everywhere. So the MCS for trucks will also make sure that we also need to charge different things. DP World, for example, needs to charge straddle carriers right now with liquid-cooled CCS, but probably also with MCS in the future. A ferry in Norway probably also will charge on MCS. We have a Epiroc example in the mining industry, and even Hard Aerospace from Sweden, who will actually create the first electric plane. And then we also have a company in the Netherlands exploring those options. Of course, this is pretty far away, but still, the MCS will have an impact also on other industries. So I think this is not made by us. This is real news. So looking at the timeline, so we have the road to higher powers, right? So we have this gap in between as well. So we have an air-cooled satellite right now, or maybe it goes up to it. So we have a 300 amp, maybe it goes up to 500 amp with boost. Then we go to a liquid-cooled satellite, either or an MCS, level 1, 500 amp. And then we have mega satellite. So we believe that also the CCS needs to be improved, and we need to be able to charge 500 to 900 amps on CCS in the future. Well, then we have, of course, the mega satellite, or the we call it the mega satellite because that's our brand name for MCS, and that will be 1500 amps, so 3 times faster the current standard in Germany. 500 amp is pretty much the standard in public charging, and it will be 3 times faster. And then looking at the level 3, that will be like MCS level 3, 3000 amp. Of course, we're talking about 2030, or from 2028 to 2030. So how are you going to combine those two things in our minds, in Kempower's minds? We need to be able to divide the power dynamically. We need to have a source in the corner and a satellite in the field to be able to combine different configurations. Otherwise, it won't work. You can't put a standalone charger in the field with an MCS plug, because if it's not being used, it's a 300K MCS charger which is not being used, which is not good for CPOs. It won't work, in our minds. So right now, this is basically what we're doing right now. So at the moment, we are dividing the power over maximum 8 plugs dynamically, making sure that, I always give the example of driving my Kia Niro with my family to Italy, charging on an Ionity charger with 1 plug, 350 kilowatt. Sorry, Ionity, saying that out loud. But charging on 50 kilowatt, most of the drivers would be happy. I have the feeling I'm hijacking 350 kilowatt. So that 350 kilowatt is not available for anyone else next to me. That's what we try to do in our current setup. So we try to divide the power equally and make sure that people that plug in at 80%, 90% state of charge do not get 300 kilowatt, which is not needed at all, of course, because most of the cars will charge at that state of charge 50 kilowatt, or maybe 25 with the older EVs. So we see that that's necessary. So how would that look like, configuration-wise? So in the corner, in the left side, you have 1.2 megawatt, 2 times 600 kilowatt. So the 2 gray machines are both 600 kilowatt attached to each other. And it could look like, I just put some configuration examples here that you put like let's put the second one or the third one. So you have an MCS satellite there. It could be used during the day, but during the night we could use the other 6 standard satellites for overnight charging. Or, and of course the holy grail would be like a reservation system within a few years, because these systems will be super expensive. But just to make sure that, of course, you will utilize the power anyhow. So to make sure that you either charge the MCS or you charge the CCS as dynamically as possible. Yeah, so what's the development goals within MCS for us? So, as I said, maximum flexibility. So connect any combination of a mega satellite and a conventional Kempower satellite to one system. Also, right now, if you invest in a 600 kilowatt system with satellites, you can still attach another 600 to, so you can invest now and you can actually transition to MCS later on, which is, I think, key for truck CPOs. You want to, of course, share the power between MCS and CCS, and indeed, as I just said, the upgradability to 2 power units of each 600 kilowatt. I'll give you a quick summary now. So in our minds, the megawatt charging is the missing link towards electric truck electrification. It will drive, the technology will drive other segments, as I just shown you. Those are real news articles out. So other machinery and vehicles will be charging, even planes, with probably MCS. Ultra-high flexibility is needed at charging sites to help the market transition. And I just want to pinpoint the last point that we made an electric traffic ecosystem called, well, the Finns would call it the Hete, but I'm not Finnish, so I'm not sure if I did it the right way. But it's co-funded by Business Finland. You can join it. You can talk about it at our stand later on, to me or to some others. It's mainly a community to talk about these kinds of developments, MCS developments, and also truck charging developments. And it will run for the next 5 years. Thanks.
Thank you so much, Han.
You're welcome.
We have 10 minutes, or 5? I think we have a little bit more.
Yeah.
Questions from the audience. Please raise your hand. We have mics over there. Okay, no question yet. There's a question in the back. Quickly, the network, the Hete thing, is that just for Finnish companies or is it European?
No, there's also customers joining that network to actually spar. And of course, we have events relating to that, but it's mainly indeed in Finland, those events.
I think there's some interested stakeholders in Germany as well, I heard.
Indeed, yeah.
What challenges do you see for the utility grid to support these use cases that you highlighted?
Well, you asked the right person, because we're from the Netherlands and our whole country is red, if you ask all the Dutchies here. So we indeed are struggling with the grid connections massively. So indeed, batteries will be a solution, but it will take at least 4 to 5 years to actually get a bigger network in the Netherlands up and running. But yeah, indeed, it will slow the transition down. So yeah, I think.
Picking up on that question, do you get signal? Like, I think currently you can't connect to the grid in the Netherlands, or you can't get a connection because, as you said, everything is red, meaning everything is congested.
Indeed.
Do you get sort of a special grid fee, or how are the grid fees if you now try to connect your 600 kilowatt satellite?
Well, I think you have to stand in line, just like any, like a school or whatever. But of course, the difference is you will always get a 3 times 80 amps connection. Yeah. That's mandatory by law. And then, of course, there's new battery suppliers that can actually use the 3 times 80 amps or 3 times 60 amps to actually create a bit bigger. But of course, for the MCS, you need massive batteries, right? So that's going to be challenging. I agree.
More questions? There's a question over here. Sorry, and a question in the front. We'll start here. We'll have you later.
Okay, Mikko Sumala, Euroloop. Thanks for the presentation. I'd really like to put a word forward for Hete, as we Finns say.
Sorry.
I was at the launch event. 169 person turned up. They were expecting 60. And it's really a network of many kinds of people. Finnish government puts in 10 million. Kempower has promised to put another 10 million in running it. So it's a major initiative for the whole industry in Europe. But as for the presentation, what we were looking at here is massive size. Sites are getting bigger, especially for fleet charging. I was responsible for running a bus fleet operation for one of the biggest fleet operators with 15 megawatts on a single site, and we used 50 megawatt hours a day. So going to bigger, I think what we're expecting is bigger charging power. 1.2 megawatts is not even enough for a single MCS. When do we see next generation power modules, maybe DC grid, and integrate this battery storage into your already good presentation?
Yeah. Well, now I have to explain our roadmap. I'm not sure if I can, but no, no, it's valid questions. I think the next step for us is, to be very honest, it's connecting the two 600s together, right? So that's the first step, which will happen next year for the first time. So also for us, it's going to be a learning by doing exercise. So, and to be honest, I think we need to go on after that. Indeed, I can't tell you specifically what we will do, but it's gonna, of course, we need, or either a different platform, or either we need to attach more of the current platform. But yeah, I completely agree with you. We need higher powers than that. Yeah. Indeed. Yeah.
We have a question over here.
Okay, thank you. Thank you for your presentation. I got a question for you. We know for HPC, we have the integrated DC charger and distributed DC charger like Kempower, and you are doing very well. But when it comes to the integrated DC charger, like the 480 kilowatt, 400 kilowatt, yes, I want to be mentioned the exact name of other manufacturer, but we know in the current market, we can see the 480 like auto, and 300 kilowatt. So what do you think what would you say when it comes to the disadvantage and the advantage of installing the integrated DC charger and the distributed DC charger? Because we have the CPO and the end customer, they have to consider the total cost. So with the increase of the EVs, now the increased EVs is going up stably. Now increasing like the 2 years before, it can going up to 20% or 30%. So more and more CPOs will consider the total cost.
Yeah.
But you install the distributed DC charger, you have to install the power unit and the satellites. So it is a challenge for Kempower, or what do you think of the disadvantages and the advantage between the integrated charger and the distributed DC charger?
You also
Thank you.
said it was very expensive, so maybe you can make up the comparison.
Basically, indeed, it's the difference between the standalone, the charger, and what we are doing. We have a standalone charger as well, but we've seen it not being sold that much, so that says a lot. But to answer your question, I think we are lucky that we are one of the market leaders on CPO charging in Norway, where there is, of course, like massive EV adoption. And we see actually there that people want to have at least 15 to 20 plugs. So the hashtag more plugs is really something we really believe in. So they don't really care to actually have 50 kilowatt or 100 kilowatts. They actually care about an available plug with sufficient power. And I think what I was telling earlier, we are gradually charging in steps of 25 kilowatt, which makes sure that you are not using a big chunk if indeed you have, well, my uncle or aunt charging on 90% state of charge. That's what you want to avoid, I think. Also, as a EV driver, you won't notice because you will get whatever you want, of course, within the system. So I think that's a big plus. for us, but also for the CPO. But we also see this in bus charging, for example. We have a case where there are standalone chargers in Berlin, where there's 105 buses, and you need 15 megawatts to charge the 105 buses. In Oslo, there's 105 buses charging on 7 megawatt with our system because of better utilization. So yeah, it's all about the, I think, power module size, what we believe in. Yeah.
Thank you. We have time for one final question. If I can ask you, so you have a huge crowd of developers and software companies here. What are the most important services that you need? Because you already said the grid integration and sort of the power balancing and all these are key and very critical for you. So what partners do you need on that side? What do you need help with?
Well, to be very honest, we have a very big partner network in Europe. So we have many resellers. We of course sell directly to customers, but in many countries like the Netherlands or Germany, we have a big group of resellers and partners we actually take very seriously. We actually have our partner days in a few weeks, which is a big event in Finland, and we actually treat them really as a we say verlenging, but how to say, like an addition to our own company.
But in terms of sort of reservation systems and this kind of stuff.
That's of course, but yeah, we are dependent on the CPOs and the back office providers to actually think of that. We actually have a reservation system in the Netherlands up and running with WattHub. It's a big case. It's 36 plugs. It's quite famous, and they made their own reservation system, but for clients they have contracted. So they get a login to a portal, and they can actually, because it's on the way from the Ruhrgebiet to Rotterdam, the charging site, so they can actually already reserve a spot on WattHub. So that's, yeah, we need those guys.
Germany has to develop there.
We need those guys, yeah.
Thank you so much, Han.
Okay.
We will be talking about trucks later on, so I hope you'll be around.
Yeah.
And for all of those who care, please join us after lunch. And thanks so much.
Thanks a lot.
To you.
Thanks.